There are many phenomena that have perplexed scientists throughout time, but one of the greatest mysteries in astronomy until recently was the gamma-ray burst. First discovered back in the 1960s during the height of the Cold War by gamma-ray detecting satellites deployed by the U.S. government to detect Soviet nuclear detonations. They were discovered when the satellites detected traces of gamma radiation coming from all directions throughout space. Not much was understood about them back then, and the phenomenon wasn't researched properly until the 1990s, when the Compton Gamma Ray Observatory was launched. What the scientists had discovered was that the bursts were occurring throughout the universe and were visible from huge distances, meaning they were incredibly powerful. Before we go any further, let's talk about what makes up the bursts. Gamma rays. Gamma rays are the smallest waves in the electromagnetic spectrum, but they are also the strongest. They are also only produced by the most powerful and destructive events in the universe, such as black holes, supernovae, and neutron stars. Shortly after their discovery, scientists had noticed a pattern. There are pretty much two types of gamma-ray bursts, one that lasts less than 2 seconds and one that lasts more than 2 seconds, the latter of which can last up to several minutes. Scientists have theorized that the short gamma-ray bursts were created by two neutron stars colliding to form a black hole, while the long GRBs were created by a supernova from a supermassive star. Regardless of the length of the GRB, they are considered to be the most energetic and explosive events in the universe, second only to the Big Bang. An example of their power would be that in 2008, for 30 seconds, it was possible to see a GRB occurring with the naked eye. The crazy thing about this is that the GRB had a redshift of 0.937. To put that into perspective, a redshift of 1 means an object 7.5 billion light-years away, or half the length of the known universe. Gamma-ray bursts are much better understood than they used to be, but even still the mechanics of them aren't fully understood. It isn't completely known how or why the energy is discharged when a black hole is created, or when a hypernova, which is a supernova from a massive star, explodes. Even still, gamma-ray bursts remain as one of the most awe-inspiring events in the universe. The scope of their power is almost incomprehensible. These events also occur all over the universe, so while they're unique, they aren't impossibly rare. There's a good chance that they occur even more often than we see, because the only times we see GRBs is when they are headed towards us, which means that more likely than not, they occur all around us, just outside our view.